Okay, did you get a chance to review and memorize the double angle formula for this one?
Is it the 1 minus 2 sine squared theta?
Yeah, there's actually three of them. Did you know that?
I know that there's 3, but I just haven't memorized them yet.
Okay, the one that you actually want to memorize is this one. Cosine 2 theta equals cosine squared theta minus sine squared theta. Okay, and so once you get this memorized, you can extrapolate the other two easily.
Okay.
So the one you mentioned was the 1 minus 2 sine theta, right?
Yeah.
So the way you do that is just replace this guy with the other identity. Remember what this one was equal to? 1 minus sine squared theta.
Oh, okay.
Yeah, and then notice the sine squared theta, there's two of them, right?
Yeah.
So you can combine it, and this will eventually become 1 minus 2 sine squared theta. Okay, do you see how that works?
Yeah.
Yeah, and the other one is just, substituting the sine squared theta. So yeah, so this is the one you want to memorize, and just tell yourself it's like the reverse Pythagorean, because Pythagorean theorem will be plus, this would be the minus. Okay, so the first thing you want to do is realize that, okay, if there's an equal sign, you have to first set it equal to 0, usually, and factor. You want to factor like terms. So we're going to turn this into 1 minus 2 sine squared theta equals sine theta, and then bring that to the left side. So this will become negative 2 sine squared theta minus sine theta plus 1. I just rearranged it. Do you see how that works?
Yeah. So for this one, I would be able to work on both sides, not just one.
Yes and no. So this is different than, okay, here, let me see. Let me show you. So the okay, so the left side, right side, is for these types of problems. When they say verify, you see this?
Okay.
So when you're verifying an identity, you're trying to show the audience that the left side eventually becomes the what?
The right side.
The one that
Okay.
you're doing is 11 through 18,
Yeah.
19 to 25, and there's a difference even with these two groups. Did you know that? Notice that this one has a restriction. You have to give an answer from 0 to 2 pi, but this one you don't.
Yeah.
Okay, do you understand how to answer both of these? Like this one, you wouldn't give an x0 answer, you give like an equation. Like a
Yeah, it'd be like, for example, pi over a plus pi n, something like that.
that or 2 pi, usually it's 2 pi n, and then for tangents is pi n. Yeah, okay, exactly. Okay, so yeah, so we're gonna restrict this to 0 to 2 pi. So
Okay.
in that situation, you want to what do you call it? Set it equal to 0, and you're basically trying to treat it like a regular quadratic, where you factor it and set each factor equal to 0 afterwards. Now, the first one is negative, negative and positive. Because it's equal to 0, you can multiply through by a negative sign, so that you can change the signs into 2 sine squared theta plus sine theta minus 1. Okay? Do that. Then, okay, so do you see how this is very similar to something like x squared plus x minus 1 equals 0, or 2x squared? So yeah, if you get confused, you can revert to this format just for, just to kind of work with it. Okay, do you know how to factor this?
Is it is this the one where it's 2ab plus?
Well, there's several different techniques. You can use, do you know how to use the x method?
Yeah, I know how to use that one.
You can use that one. You could just do it in your head if you can. But you're familiar with the x method, right?
Yeah.
So it'll be 2 times the last number, which is negative 2. You put that on top. Then you put the middle term on the bottom, and just come up with two numbers that will multiply into the top, but the two numbers in the middle will add up to the bottom. Obviously, it's going to be 2 and negative what?
Negative 1.
Yeah, negative 1. And then you have to rewrite the equation as 2x squared plus 2x minus x minus 1 equals 0. Okay, do you get that part?
I'm still a little confused on that part, like the 2x squared plus 2x.
Yeah. So you see these two right here? These are the numbers that we just found out, right? 2 and negative 1. They actually become the two middle term right over here.
Oh, okay. I do remember this, I
Yeah,
think.
which
Yeah,
basically adds up to the middle term that you see right over what?
in the middle.
Yeah, so 2x minus x should actually equal x. So basically what you're doing is you're taking a three-term quadratic into a four-term.
Okay.
And now you can factor the first two separately and the second two separately like this. And this will become 2x, x plus 1. And then for the second group, if you factor out the negative, it will also become x plus 1. And you'll notice that both of them share x plus what? Plus 1?
X plus 1.
Yeah, and there's like an invisible coefficient of 1 in the front, negative 1. So you make this into 2x minus 1 and x plus what?
X plus 1.
Now we have to revert this back to the trig form. So x will be like a sine theta. So this will become 2 sine theta minus 1. Oops. And sine theta plus 1. Okay, is that
Okay. I got the same thing. Yeah, 2 sine theta plus
right.
1 or minus 1.
So yeah, so now you set each factor to 0. 2 sine theta minus 1 equals 0. And sine theta plus 1 equals 0. And then you have two solvable equations, or two equations to solve. Okay, so now here, what you're going to do from this moment is you're going to try to make these trig functions equal to one of the terms in that chart that I gave you.
Okay.
All right. You want to did you memorize the chart?
Not yet, but I'm going to.
You and Adeline, you
I
have
really
to memorize. It's so helpful. Like it's gonna.
I know. I promise I'll memorize it today.
Okay.
I really need to.
All right. So here, I'll just write it real fast. Okay. So sine, cosine, tangent. Okay. 30, 45, 60, pi over 6, pi over 4, pi over 3, 1/2, rad 2 over 2, rad 3 over 2, rad 3 over 2, rad 2 over 2, 1/2, rad 3 over 3, 1, rad 3. Okay, that took like, I don't know, like 25 seconds.
Yeah.
And boom, you have everything you possibly need for, to ace this exam. So you see all these numbers right here, the 1/2, rad 3 over 2. These are the numbers that you're trying to set this equal to. Oh, not that one, sorry. This one. So if you notice, if you move the 1 to the other side and divide by 2, you get sine theta equals 1 over what?
2.
Guess what? In our lovely chart, there is a 1/2 right here under sine. And what angle is it pointing to?
Pi over 6.
See, the answer is just given to you, right?
Yeah.
So this theta has to be what? Pi
over 6.
But this is quadrant 1. There's two quadrants where sine is positive. Do you remember what those are? Quadrants 1 and 2, sine is positive, remember?
Oh, okay. So is
theta, yeah, if theta is pi over 6, it will equal 1/2 because 1/2 is a y coordinate, isn't it?
Yeah.
Now on quadrant 2, if you go this way like that, you'll also have a y value of 1/2, which will be theta equals 5 pi over.
Excuse me. Sorry.
Bless you. 5 pi over 6.
Okay.
Okay. Do you know how to get this?
The 5 pi over 6, is it basically just using the negative one you said? So like going back?
Kind of. Okay, on the unit circle, there's two places where sine values are positive. It's quadrant 1 and quadrant what?
Quadrant 2.
Yeah. So watch. In quadrant 1, if the radius goes up pi over 6 degrees, do you remember this?
Yeah.
The y value will be 1/2. But on this side, you have to kind of angle it this way. So this little space right here is also pi over what?
Pi over 1/2.
Yeah, pi over 6. Yeah. But we have to count this angle counterclockwise from the origin. So if you go from here to here,
it's 5 pi over 6.
5 pi over 6. Yeah, you can go pi minus pi over 6, or just add 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Or in the worst case scenario, change everything to degrees and then turn it back into radians. Okay, does that make sense?
That makes sense, yeah.
Okay, so you now have two solutions, that one and that one, but you have to go to the second factor, and you have to do this. Sine theta equals what?
Negative
-1.
1.
Now, the chart, I didn't put the 0 or pi over what?
Pi over 1.
Yeah,
Or
pi
pi
over 2. Because these are numbers that are on the x-axis, y-axis, x-axis, y-axis. Those are
Yeah.
more of like, you can just reason it out thinking about the unit circle. So when is the sign value on a unit circle -1? There's only one place.
It's
When is the y value -1?
Y value.
Remember the unit circle?
Yeah, it's -1 like
Right here. See this?
yeah, right there.
So what angle is that from the origin?
Oh, is it 2 pi over 3?
3 pi over 2.
Oh, okay. 3 pi
Okay.
over 2.
So this, okay, look, this right here is pi over 2, right?
Yeah.
So 1 pi over 2, 2 pi over 2, 3
3
pi
pi.
over 2, and 4 pi over 2. So this would
Okay.
be 3 pi over 2. Theta
Okay.
equals 3 pi over 2. And again, that's within the restriction.
Yeah.
All right, good. And then you know, definitely review the video and try to listen rather than just, you know, trying to follow what I wrote, really listen to the reasoning so that in
Mhm.
class, a similar problem that you have, you can also reason it through.
Okay.
Okay. All right, what else?
I think this was the last one that I was able to try. So I think from here, just like whichever ones are probably the most.
Okay,
that
let's
you think
flip flop
Okay.
for the sake of time. Let's do some of this too. So
Yeah.
let's try number 19 and then we'll go like up and down. But keep
Mhm.
in mind, 19 to 25, there's no restriction. They just want you to what?
The whole answer, like the
They want you
equation.
to give an equation that gives every possible what? Answer.
Every possible number.
So 19, oops, sine x plus rad 2 equals negative sine x. Now again, you might be asking like, should I factor? What should I do? Well, if you see common terms, try to like just simplify it. And what you're looking for is a way to set that equal to one of these 9 what? These
And
9
then
digits. Does that make sense?
yeah.
Like rad 2 over 2, rad 3 over 2, like one of these guys. And you realize, hey, there's already a rad 2 here. Do you see this?
Yeah.
And you're thinking, just kind of do some stuff in your head. If I brought the sine x to here, it'll become 2. Bring the radical 2 on that side, that'll become negative rad 2. Divide both sides by 2, and you end up with a digit in here called radical 2 over what?
Over 2.
Uh-huh. And the reference angle is pi over 4, or 45 degrees. See how easy this is? Do you really not want to memorize this?
Yeah, I will memorize it for sure.
All right, so that's how you have to kind of reason these trig functions out. So here we go. So this would be 2 sine x equals negative rad 2. And then you divide by rad 2 because you realize, oh, that's one of the digits that's found on that chart. Even if it's a negative, so sine x equals negative rad 2 over what? 2. So now before you jump in, we know that the reference angle is pi over 4 because that's what the chart says, right?
Yeah.
But the question is this, which quadrant are we referring to? Remember, all of the numbers here are quadrant 1. Get it?
Okay, so all quadrant.
These are all quadrant 1 answers, so they're all going to be positive. And
Yeah.
pi over 6, pi over 4, pi over 3, those are also quadrant 1. So we know, again, the reference angle is pi over 4. So here's the question. Which quadrants will sine be a negative answer?
3 and 4.
Exactly. So we go like this. Quadrant 3, quadrant 4. And try to use this little t-chart that I'm making. It helps you organize your thoughts. Okay, so the question is this. If the reference angle is pi over 4, then if I crank it counterclockwise to quadrant 3, what would it be in actuality? So this angle right there is pi over 4, right? That little reference angle.
Yeah.
But if you add it from, you know, from the origin, what would it be in terms of quadrant 3 angle? 5 pi over 3. I mean, I'm sorry, 5 pi over 4. Do you get that? Okay, here, watch. So in quadrant 1, it's pi over 4, right?
Yeah.
So it's all
count.
You count by fourths. So you go 1/4, 2/4, 3/4, 4/4, and then what?
5/4.
Yeah. So you basically break up the top into 4 equal like wedges.
Mm-hmm.
And then you go an extra pi over 4 right here. But if you add it up all the way here, then that becomes 5 pi over 4. So what do you think it is in quadrant 4 then? We keep on adding by fourth.
So this is 5 pi over 4. So are there 4, like the top part and then the bottom part, right?
So yeah, 4 on top, 4 on the bottom. So it's 1, 2, 3, 4, 5, 5, 6, and what?
7 pi over 4.
So this would be 7 pi over 4. Okay. So okay, do you see how that works?
Yeah.
So the denominator basically tells you how many sections you need to break up the upper half and the lower half.
Okay.
Yeah.
So it's just like, oh, sorry.
No.
It would be 7 pi over 4 just because it's like the first one that reaches that quadrant, right?
Yeah, exactly. So it's like this. But this spacing right here would be pi over what?
Pi over 4.
Yeah. So we want that angle to the horizontal line as a reference angle. But to get there, you have to go counterclockwise from the origin all the way what?
All the way down to
Yeah, all
7
the way
pi.
around like this. So
Okay.
we'll take 7 pi's over 4s. Now, but the question is this: is that your answer? And the answer is no. Those are the actual angle within 360 or 2 pi. So you have to go like this: x equals 5 pi over 4 plus 2 pi n. X equals 7 pi over 4 plus 2 pi what?
2 pi
So
n.
that's the answer on the answer key.
And then there's something where you have to like, this might be for the wrong problem, but you have to like check it, right? Or not check it. Yeah,
you have to combine the two equations into one, because instead of using 2 pi n, you can just use pi n.
Okay, how would you know when to do that?
Okay, so it's usually for tangents,
Okay.
and usually for answers on the x and the y axis. Which one? Let's see. Let me see if I can find one. Yeah, like 21. Okay, so 21 is a classic example of that. So again, do you understand that 2 pi n is basically like a way to just say start from 5 pi over 4 and just go around 360 degrees until you get back to the exact same point. So 5 pi over 4 is here. If you add 2 pi n, 2 pi would be 360, right?
Yeah, 360.
And the letter n just means how many times you're going to go around.
Okay.
So n just means you can go around again and again. See it?
Like as many times.
Yeah. Mm-hmm. So this one right here, so again, you're like, okay, what do I do with this one? And you kind of see a square, and you think about, again, if you're lost, just go back and look at your what?
The chart?
It's a chart. You're like, tangents, okay, tangents are rad 3 over 3, 1, and rad what?
Rad 3.
3. So, if I took the square root of both sides, what would happen? On the right side, you'll get rad 1 over rad what? 3, which basically is 1 over rad 3, right?
Yeah.
But you have to rationalize it, so you have to go rad 3 over what?
Rad, or positive 3. Not positive 3, just 3.
But don't forget, when you square root both sides, you get two answers, a positive and a what?
Minus.
Yeah. So what you have to do is you have to now split this up into two. Tangent x equals positive rad 3 over 3. Oops. And tangent x equals negative rad 3 over what?
Rad 3.
Yeah. Now, what's our reference angle according to our handy-dandy chart?
It would be pi over 6.
Okay, pi over 6. Now, again, the question is this. So we keep that in mind, and then we ask, what quadrants is tangent positive?
Positive in...
Obviously, 1, right? Everything is positive in quadrant 1.
Oh, yes, everything's... Yeah, 1.
All are... But what about... what other quadrant is tangent positive?
Is it also positive in 4? Oh, 3.
3, because on quadrant 3...
Oh, the negative over the negative.
Right, negative over negative, right, okay. So You put that there. Okay, see how doing this really helps you organize your thoughts?
Yeah.
Okay. So, and every trig function will have like usually two options. So the question is this: in quadrant one, what's our reference angle? Well, our chart gives it away. It's x equals pi over 6, right?
Yes. So pi over 6.
Uh-huh. So we can go. So you naturally just write this: x equals pi over 6 plus 2 pi what? 2 pi n. Meaning just naturally just start off with that. Okay. And
Okay.
then for the third quadrant, okay, let's see if you can do it. What's the angle in the third quadrant if your reference angle is pi over 6? Can you start counting your 6?
Yes. So pi over 6 starts in the first 1, 2,
So the top part has 6 parts, right?
2, 3. Wait, so pi 6.
You should get 7 pi over 6.
7 pi over 6?
7 pi over 6, good. X equals 7 pi over 6 plus 2 pi what?
Plus 2 pi n?
Yeah. But tangents, the two angles, do you notice that they're pi units away from each other? They're like 180 degrees. So here's pi over 6, and here's 7 pi over what?
7
6.
pi over
It's
6?
exactly pi units away. You see it?
Yeah.
So you realize, hey, instead of going 360 degrees around back to pi over 6, can I just start from pi over 6 and add pi and get to the other answer, and then go back to pi over 6 by adding pi continuously? And
Yeah.
that's what they're talking about. Now you can take these two and combine it like this. X equals pi over 6 plus pi what?
Pi 7 pi
n.
over?
No. Because when you add pi n to pi over 6, you will get 7 pi over 6 again.
Oh, okay, that makes
It'll
sense.
produce that answer for you. Does that make sense?
Yeah.
Yeah, and that's what you have to see. And again, it's always usually, I don't think of any other situations. It's usually for tangents, okay? Tangents will always be a pi n, but notice you don't want to give the other answer because it comes out when you add pi 6 plus pi, right? Yeah. And then now, okay, try this one. Try this one right here.
Oh, the 10. Okay.
Yeah, give that a try. So give me the two quadrants that it's negative.
So it would be in quadrant 2 and quadrant 4.
Yes, good. And
then it reaches quadrant 2 with 1, 2, 3, 4, 5. So 5 pi over 6 for quadrant 2.
5 pi over 6 plus what? 2 pi n?
Oh, pi n, yeah.
And then the other quadrant 4 will be what?
It would be 7 pi over 6, 8, 9, 10 pi over 6.
Can you go one more?
Oh, 11 pi over 6.
Yeah, because that's right before 12 pi over 6, right?
Oh, wait, did I count it wrong or?
Here.
Pi over 6.
So you got 1, 2, 3, 4, 5, 6, right?
Yeah.
And then you go 1, 2, 3, 4, 5, what?
6.
So this is 7 pi over 6 right here. 7, 8,
Oh,
9, 10, and what?
11.
11 pi over 6, yeah.
Oh, okay.
Pi over
Wait,
6?
I'm so
pi over
confused.
Yeah.
So why would it not be the 10 pi over 6?
Here, because look, it's always about the horizontal line, like this right here. Pi over 6 is one, basically, it has to be pi 6 distance away from here. Here, it also have to be what?
Pi 6
Pi
distance?
6? Pi over 6. So this right here is what? Pi 6 units away from the origin.
Yeah.
So
this is
that
10
makes
pi
over
sense.
6. It's two units away, or 2 pi 6 units away.
Okay.
Yeah.
I'm gonna have to write that down.
Okay, so now so do you notice that right here? So your answer was 5 pi over 6 and 11 pi over 6. So do you see how it's 180 degrees away from each other, or pi units away?
Yeah.
So what would you do with these two? Can you combine them? Well,
Yeah.
one of them produced the other one and vice versa.
Yeah.
Yep. So what would it be?
It would be 5 pi over 6 plus pi.
Pi n. Yeah. I mean, it is
Okay.
pi, but n just means keep on what? Keep on
Keep on
going.
going.
Yeah. Once you hit 11 pi over 6, add it again, you're back to where it was originally, and then it'll just keep on going in circles.
Okay.
Okay, so these two are the answers for number
21.
Okay, that was your question, right?
Yeah.
There was one other one. Let me see if I can find it. Yeah. The 20. Okay. All right, let's try
20.
let's try number 20. Okay, so tangents will always have like a pi n, but what about other situations? And the other situations are when you have a number on the y-axis, like at pi over 2, or see, like basic. Okay, we'll see. All right, so do you see how this is a quadratic situation? You have like an x 2x squared x and 1.
Mhm.
So you set equal to 0 and you factor it. Okay, do you want to try that real fast? Factor this
Yeah.
using the x method. And if you have to, convert it to like 2x squared minus x minus what? Minus 1.
Okay.
You said it. All right, try it. Okay, did you get something like this?
2 sine x. Yeah, I got 2 sine x minus 1 times sine x plus 1.
Oh, you already factored it out? Okay, so
Yeah.
be 2 sine x plus 1, sine x minus 1. Is that what you got?
I did.
Oh, did you have 2 sine x minus 1?
Yeah, and then sine x plus 1.
Okay, so let's see. Check your work. Okay, so it multiplies into -2, right? And then it's got to add to -1. Did you put that on the bottom?
I did sorry, I did -1 and +2 instead.
-1 and positive. Oh, I see.
So yeah, I just
-2.
wrote that wrong, I think.
Wait, did you get this right though? Up here, -2 and -1?
Yeah.
Okay.
Oh wait, negative? Yeah, I did. Okay, sorry. -2 x.
So let's set both equal to 0. 2 sine x plus 1 equals 0. Sine x equals 1. Okay. How far did you get? Did you get to this point?
No, not yet. I'm almost there.
Tell me when you get there.
Okay. So I got to the sine x equals -1/2 and sine x equals 1.
Okay, so all right, so let's finish this one first. Did you set it up as 3 and 4?
3 and 4, yes.
Okay, try it. Give it a shot and give me the two quadrant solutions. And again, this is a part of the just solve. Like there's no restriction, so you have to give an equation as an answer.
Okay.
All right, utilize the chart. The chart. We should write it as a capital THE, the chart.
So it would be pi over 6 for quadrant 3.
Wait, no.
6 plus.
Wait, pi over 6 is a quadrant 1 answer. It's a reference angle.
Oh, okay. So it
So
would be over 6 is the reference angle, and then I have to count. So for quadrant 3, it would be, sorry, I think I wrote it too tight.
the silence is killing me.
I didn't have enough room, so I had to erase it. But I think it is x is equal to 7 pi over 6 plus 2 pi n.
Yes, 7 pi over 6 plus 2 pi n. Thank you.
X equals 11 pi over x.
Yes.
Okay, plus 2 pi n.
Okay, so we're done with those two. Now
Yes.
go to the second one. All right, how about this one here?
So it's positive, so it has to be the first one. And the sign is.
How many places is sine a positive 1 value? Just one.
Just
Where on
one.
the unit circle? Is the
It's
y
on-
coordinate 1?
It's on the first one, like right here.
Yeah. So what is that in terms of or angle or radian?
Oh, sorry. Pi over 2.
Yes. And
So do you just write it like x equals pi over 2?
no, but remember we want every possible answer where we go right back to it. So we have to add what?
Plus 2 pi n.
Yeah. You know, hold on. Let me check the answer here again. Because I think.
Yeah, that's right.
What? I thought the answer key said pi n, so I chose this thinking that this would be like a. But there's a Well, okay. So I don't see any. Okay, I don't see any problems with the pi over 2 plus pi n. But like, if you had something like sine x equals 1 and sine x equals -1, this would be pi over 2 plus 2 pi n. Oops, pi over 2 plus 2 pi n. And for -1, it will be 3 pi over 2 plus 2 pi what? N?
2 pi.
But then notice, if I just keep on adding by pi n, wouldn't I end up getting 3 pi over 2 from pi over 2? So you could combine those two and go pi over 2 plus pi what?
Pi n.
Yeah. Now, it might come out on the test, but what I'm saying is, usually the pi n will always be for tangents, but occasionally you'll see it for sine or what?
Sine
or
or
cos. But so you have to kind of think about this, like, oh, okay, from pi over 2 to 3 pi over 2, hey, that's just 180 degrees away from each other, so might as well just do pi over 2 plus pi what?
pi n.
Okay, so
Okay. Is it okay if I write down the example?
Yeah, I'll just put right here, example. If this was on the test. Here's another example. Like if it was like cosine of x equals plus or minus 1, then for cosine of x equals 1, okay, when is cosine of x 1? When is the cosine value 1?
It's positive 1 on 0.
0. Yeah. Plus, okay, so I'll put like this, 0 plus 2 pi n. What is a negative? When is it -1?
It's not 2 pi. It's
Pi.
pi. Yeah, not 2 pi.
Okay, now if you saw this in your work, can you combine these two? This is 0 plus 2 pi n, that's all the way around. This is starting at pi and going all the way what? Around. But can I just start at 0 and just keep on adding by pi instead of going? Yeah. So how would you rewrite, how would you combine these two?
Would it be just 0 plus pi n?
Yes, that's right. And then, eventually you can just say, hey, it's just pi what?
Pi n.
Adding 0 is just nothing, right? Okay, so you'll have that. You might have that, okay? I mean, I've seen this. So so these are the only two situations where you'll have like a sine and cosine producing a pi n as your answer. Okay, good. All right, so we did that. Let's do something on the first part. Oh, did she do she didn't do any. Okay, number 25. Can you ask her?
Yeah.
Yeah, I can do it. You know what? Okay, I'll do it.
Okay, number 25.
No, wait. So wait, hold on. There was one on our worksheet on the identities.
Oh, was it number 10 that we spent a lot of time on the last time? Or is it something else?
No, it's not 10. Oh, number 5.
Oh, she wrote something on the board about that one. I did that one in class.
Did she? Oh, she actually did it in class?
Yeah, she said to do, so it's 1 minus cosine parentheses 2x equals tan squared x parentheses 1 plus cosine 2x. And then she had us write it as 1 minus parentheses 1 plus 2 sine squared x.
Okay.
And then you just go from there. Oh, wait, sorry, that's the wrong thing. She made us work on the right side. So we did tan squared x parentheses 1 plus 2 cosine squared x minus 1.
Yeah.
And we turn the tan into sine squared x over cosine squared x.
And then you multiply it in?
Yeah, and then multiply it by 2 cosine squared x, which gives you 2 sine squared x.
Okay. All right.
Yeah.
That's good.
I'm going to have to redo that one, though, because it's a little confusing still.
All right. Let's see. Let's do number 25.
Okay.
This one's actually a hefty one. All right, here we go. So again, it says solve, but no restriction. So we have to give like an equation as an answer. And you're wondering like, oh man, what is this 4x? And don't jump and use the double angle here. So when you're solving, you don't have to use the double angle formulas.
Okay.
So when solving, don't convert this to like the other, cosine double angle x. And I'll show you why. Now, do you notice that it's already in factored form?
Yeah.
So anytime you're solving, having it in factor form, it's already done. Like you're pretty much done. You just have to set each factor to what?
To 0.
Yeah, so this will be cosine of 4x equals 0. Sine squared x plus 1 equals what?
Equals 0.
Okay, now let's take a look at this. Now, this is the 4x seems a little bit confusing, but try like this. For right now, just zone it out. Don't even think about it. Okay? Meaning, what should cosine of this angle be so that you produce a 0? When does cosine become 0? And there's two situations.
Becomes 0 when it's is it 0 and then
No,
pi?
at 0, cosine value is 1. Cosine is an x coordinate.
Oh, yes. Pi over 2 and 3 pi over 2.
Okay, so look. See it? Now, they're not quadrants because pi over 2 is on the y-axis, right?
Yeah.
So, I made my little t-chart because there's two situations where cosine will become a what? A 0. Okay? And you realize, oh, pi over 2 and 3 pi over 2, they're pi spaces away from what?
From each other?
From each other, right? Okay. Hold on. Let me see. Just double check something. Yeah. Okay. So instead of doing both, we can just say, okay, I'm going to just use pi over 2 plus pi what?
plus pi n.
Yeah, but hold on. We're not, see, this is the part where it's a little bit tricky. So inside this parenthesis, we want to plug pi over 2 in there, right?
Okay.
It's normally like the letter x, you know what I'm saying?
Yeah.
And then we will say, oh yeah, so x has to equal that. But
Mhm.
instead of x, what's sitting in there?
A u?
No,
Is it substitution thing?
a 4x,
4x, yeah.
right? So what you do is you take the 4x and just put it right here. So 4x has to
Okay.
equal pi over 2 plus what?
Plus,
Now, did Miss Town do like a u substitution or something?
yeah, she did u.
Okay, I mean you can like here. I'll do it for you then. So just to keep consistent, but it's like the same thing because you have to bring it back, right?
Yeah.
So if cosine of u equals 0, then u has to equal pi over 2, and u equals what? 3 pi over 2. But
Yeah.
you realize it can be pi over 2 plus pi n. But what exactly is u? It's 4 what?
4x.
Yeah,
So
so
4x, and then just solve.
No. So now, well, isolate x by dividing everything by what?
By 2.
By
Or
4.
by 4. By
Yeah,
4.
like that.
Yeah.
Everything like that. Now, dividing by 4 is same thing as multiplying by 1/4. You want to try it that way.
Okay.
So just go like this. Multiply this by 1/4. Multiply that by what? 1/4. And 1/4 times 4 is just x. So the answer now is x equals. This would be pi over 8 plus pi n over what?
Pi n over 4.
Yeah, I think that's the right answer. Yes, pi over 8 plus pi n over 4. Okay. This one you might have to just review this again to make sure you get the answer. I mean, to get the idea. So basically, just treat the 4x like a letter, like a u, and we're just looking for the angle for that parentheses. Whatever the angle you find, set that equal to u, and then replace u back with the original representation of 4x.
Okay.
Yeah. Okay. So, all right. Now again, do you see why we wrote this?
Yeah. Because it's pi away from each other.
Pi away from it. Yeah. So there's no need to repeat 3 pi over 2. It's included in this equation right there.
Okay.
Wow. Okay. Well, see, we're not even done. That's only 50%. What about the other one? Can you do that one? Here. Why don't you do this one? Try it by yourself.
Okay. Oops.
If you took more than 5 seconds, something's wrong. You know why? Do you notice that it's equal to -1?
Oh, yes.
Did you square root it? You did, huh?
I did square root it.
Okay.
Okay. No solution.
Why? Why is it no solution?
Because you can't square root a negative.
Yeah, you cannot take square root of a negative number. Okay. So there's no need to even finish this problem. I think the other video had all the identities, right? We just I think we did most of it. So you can watch those videos. This one will be just more of the solving stuff. Let's do. You have a preference? Do you want me to just choose?
Yeah, it could be whichever one. It's starting to like make more sense though.
So last time we got up to number. What did we actually? Okay. Oh, we just did like identities last time, right?
Yeah, I did 1 through 12 so far. And then the only things that I haven't done is like 13 through 18, and then also like the ones that we didn't do together for 19 through 25.
Okay, so let's do 13.
Okay.
Okay, 13, 2 sine theta cosine theta equals rad 2 over 2. Okay, you're thinking like, okay, do you notice that rad 2 over 2 is one of the numbers on our chart?
Yes.
Okay, so if it's already on the chart, we don't want to change anything, okay?
Oh, okay.
Because if you divide both sides by 2, it's going to turn into rad 2 over 4.
Yeah.
It's not on the chart, right?
Yeah.
So once it appears on the chart, then you have to ask, well, do I have to do something with this guy? Yes. Do you notice that this is a double angle for something?
Yes.
Which one? Find it. Oh, I just gave it to you. Sine 2 theta.
Wait, sine square theta or sine 2 theta?
Sine 2 theta.
Oh, okay.
Yeah. Now this one, they want the answers from 0 to 2 pi. Okay, so we're going to treat this 2 theta like the letter what?
Like the letter U.
Yeah. So what should u be so that sine of that becomes rad 2 over 2? What's our reference angle according to our marvelous chart?
It is pi over 4.
Yes, pi over 4, but which quadrant is sine positive?
Only positive in the first one, and is it quadrant 3?
No.
Wait, quadrant.
Okay, what coordinate does sine represent?
A Y.
So which quadrant is y positive?
It's quadrant 1 and quadrant 2.
1 and 2. Good. So now quadrant 1 is u will equal pi over 4 plus 2 pi n. And in quadrant 2, it'll be u equals what? If the reference angle is pi over 4, what is it in quadrant 2 then?
Pi over 4 has to go to 2, so it's
1/4, 2/4, and
3/4.
3/4. So 3 pi over 4 plus 2 pi what? N. And then replace the u back with 2 theta.
So I was a little confused. For the 3 pi over 4 plus 2 pi n, you would
this one?
yeah. So you would do it. It would be like pi fourths away from the
horizontal line.
the horizontal line, right?
Yeah. So here, so this would be pi over what?
Pi over 4.
So that means you're gonna break it out to 4 equal parts. So you have to go like this, right? So this would be 1/4, 2/4, 3/4, and what?
Oh, okay. I think I keep thinking.
Yeah.
Oh, okay. I just keep thinking it. I keep thinking of it as like the space instead of the line itself. If that makes sense.
Oh, you mean this? This part?
Yeah, I'm thinking like that segment is 3 pi over 4 instead of just the line being 3 pi over 4, and then I keep getting confused on that.
Yeah.
Okay. So, okay. Thank you.
All right. All right, hold it together. I feel like you're kind of zoning out a little bit, huh?
No, it makes more sense though. It's just like that. I keep getting confused on that part for some reason.
Okay, now what do we do from here?
And then we have to wait. You can't replace this, right? So you would have to leave it. Yeah. So you would replace it with the 2.
2 theta.
Equals pi over 4 plus 2 pi n, and 2 theta is equal to 3 pi over 4 plus 2 pi n. Wait,
And
yeah,
then, and then divide it or let's just multiply. Multiply through by 1/2.
Okay. So theta is equal to pi over 8 plus pi n.
Yes.
And then theta is equal to 3 pi over 8 plus pi n.
There we go.
Okay.
Oh, wait. Sorry. Are they asking for? Oh no, this is number 13. So they want the actual answer. So just pi over 8 and what?
Oh, 3 pi over 8. Okay.
Yeah, sorry, I thought this was the latter half. Okay, so yeah. But do you notice like when we learned it, we learned this first. We're supposed to write it as pi over 8 plus pi n, and then when they say give the answer less than 2 pi, we would just scratch that out and circle those.
Okay.
But every year they, I guess some teachers want, or they feel like the students can actually learn better that way, so it's fine.
Yeah.
Okay, good. Let's keep going. Here, do you want that identity for you, number 5?
Sorry, what was it?
Do you want me to do this one real fast? The identity, the one that we, or do you?
Oh, yeah, sure.
So she said work on the right side. So this will be sine squared x over cosine squared x, and this will be 1 plus 1 minus. Oh no, that'll be 1. This will be 2 cosine squared x minus 1, I believe. Yeah.
Okay, yeah, 1 minus 2 cosine. Is this the same thing that can be reduced or reduced from the cosine squared x?
Yeah, so let's see, cosine squared x minus sine squared x, right? And then you can just replace the sine squared x with 1 minus cosine squared what?
Oh,
And you
okay.
distribute the negative. So you get cosine squared x minus 1 plus cosine squared x. And then cosine squared x and cosine squared x adds up to 2 cosine squared x minus 1. Now,
Okay, and
it might actually be just worth the time to memorize the other two.
yeah.
So yeah, when I did this first time, I didn't even think about switching using this one, so I got stuck. Okay, so let's work it out. Let's multiply this through. This times that. This times what? That. That'll
Mhm.
become sine squared x over cosine squared x plus. Oh wait. Sorry. You know what? I just realized we can subtract the 1 and get rid of the 1, right?
Yeah,
So this would be sine squared x over cosine squared x times 2 cosine squared what?
squared x.
And then cosine squared x will cancel out like that.
Mhm.
See it? And then this will be
Sine squared x.
2 sine squared x. And then replace the sine squared x with 1 minus cosine squared x. So this will be 1 minus cosine squared x. Oh, I think it's working. 2 minus 2 cosine squared x. Can you check your notes? Am I on the right track? Did she do it? Did she work it out in class?
Yeah, she did. So all she did was the sine squared x over cosine squared x times 2 cosine squared x.
Yeah.
And then she got 2 sine squared x, which
Yeah.
is equal to 1 minus cosine 2x.
And she just left it like that?
Yeah, so she just went from 2 sine squared x to 1 minus cosine
So
2x.
this is written wrong. Do you see it? Wait. But this is not this side. Like, did she just stop here?
Yeah, I don't know. I just wrote what she had on the board because it was like towards the end. But 1 minus cosine squared
Wait,
x.
you have a class. Oh, yeah, it's on Wednesday. You don't have class tomorrow, huh?
No, I don't.
Can you email her? Like, take a picture of, just write, copy this down and say, like that. Say, where do I go?
Oh, okay. So it
Because
stopped
it doesn't.
2 sine squared x.
I mean, I'll admit I don't know everything, but I know how to do this one.
Yeah.
Either I just can't see something simple, or it's written wrong because this does not turn into
Rigid.
that.
Yeah.
Does that make sense?
That makes sense. Yeah, because you can't like get rid of
Does
it.
Does it?
Mm,
Well, here, you know what? Wait, 2 minus. So here, I can verify right now. So watch, 1 minus. I could turn that into 2 cosine squared x minus 1. That become 1 minus 2 cosine squared x plus 1. 1 plus 1 is 2. 2 minus 2 cosine squared what? X?
mhm.
Oh, it does work. But the thing is, you can't go from here back to here without using the watch, this is 2 minus 2 cosine squared x. So how do we go from here, which is this, back to this one? Now, do you see what happened from here to here? You would
Yeah.
have to take this 2 and split it into what? 1 and
Two-
1.
Yeah.
Okay, so yes, it does work, but this method is actually like it's a little bit more advanced.
Yeah.
But how would you know to take 2 and split it like this, right?
I'll ask her if something's going to be like that on the test tomorrow.
So for this one, the only way to actually solve this would be to do it from both sides until both sides are the same. So just email her and say, I realized that if you did the left all the way down, you'll get this, and you'll get what?
2
That?
minus.
Like, I mean, you will eventually get both equal to each other, like this. But
Yeah. Not in that
I
form.
ask her, like, if I was on the right side, what would I do to here to go back this way? Gosh, it's literally 1 hour. Oh my goodness. Okay, so yeah, just you definitely want to take a picture and email it to her and ask her, can you give me a hint? Real fast before time runs out. This is a situation where here you have to square both sides.
Okay.
So you'll have to go like this, like that,
Okay.
and then this will become secant squared x plus 2 secant x. If I run out of time and you need help on this one, just let me know and I'll send you try to do a video on it.
Okay, thank you.
Yeah. And then let's see. Something will cancel out. This will probably be, well, I can do this. This will become 1 plus tangent squared x. So 1 will cancel out. And then this will become 2 tangent squared x plus 2 secant x tangent x equals what? 0. And then you factor out tangent x. Well, is that going to work? Or do I have to do... do I have to get common denominator? Okay, I'll send you the work. It's gonna take me about a minute more to do this. But yeah, usually when there's really nothing to do, you will square both sides, work it out. Something's gonna cancel, and then you can factor it out and set it equal to 0.
Okay.
All right, so that's about it for today. Tangent x, sine x, or cosine. My next student's calling me. Okay, see you later.